Hello, Algebra 2. I want to teach the lesson 11A called the law of sines. Law of sines is used when you don't have a right triangle. If you have a right triangle, you can just use your sine, cosine, and tangent to find the missing parts. But a lot of times you don't have a right triangle, so you're going to use the law of sines. Now, there are a couple things about the law of sines. First of all, it could give you information, and when you plug it into the law of sines, you might come out with a sign that's bigger than 1. Well, it's impossible to have a sign greater than 1 because the side opposite can never be longer than the hypotenuse. So if it comes out like that, that's a no answer kind of question. Then there's something called the ambiguous case, which I'm going to do a problem and show you how to do it nice and systematically so it's easier to do, where they give you an angle, the side attached to the angle, and then another side, and you don't know whether that angle is like this or like this. So you actually have two answers because you don't have that third side. You have two different triangles that could be drawn. So that's called the ambiguous case. They also show you the area equation for a triangle that's not a right triangle. And that's kind of easy to do. All you have to do is plug into this equation. So let's say they gave you angle A and they gave you these two sides. Well, all you have to do is do 1/2 this side times the sine of that angle. Because what that'll do is it'll give you the height. The sine of the angle times c will be the height because that forms a right triangle. Okay? So that's the equation. So these two sides are the sides on either side of the angle they give you. If they don't happen to give you the angle but give you the other two, just use the fact that 180 minus the two angles gives you that other angle. So I might do that. I might do one of those in the homework problem. But right now, let's go ahead and tackle an ambiguous case. The law of sines says that side A over the sine of angle A equals side B over the sine of angle B. And you can use that to solve. If you have 3 of those things, you can solve the 4th thing. And if you solve for the sine, then you would just use your calculator and do second sine, put in the sine, and it'll give you the angle. So let's go ahead and do an ambiguous case here. You don't even have to draw the picture with this. You just immediately list everything. You have angle P, angle Q, angle, let's make R your third one because we know there's 3 angles. Then we have P, side Q, and side R. So angle P is 24. And since you have 2 possibles, they're both going to be the same because it's given. We don't know that one and we don't know that one, and they're going to be different for each one. So you see you have 2 different triangles here. P is 9, so P is going to be 9 on both of them. Q is 12, so Q is going to be 12 on both of them. R, we don't know. So let's use the law of sines to find missing parts. So we have P and we have P. For the law of sines, you have to have a pair. You have to have an angle and the side across to use the law of sines. In other words, a situation where you know an angle, a side, and an angle, or 2 angles and the side. Angle, angle, side, because you can always find the third angle, or angle, side, angle, and you'll be able to use the law of sines. So let's go ahead and do this problem. So P over the sine of P equals Q over the sine of Q. So let's use our calculators to find that. We cross multiply. So we have 12 times the sine of 24 equals 9 times the sine of Q. So 12 times the sine of 24 is 4.88 equals 9 sine of Q. And do 2 to 3 decimal places to make sure you get an accurate answer. Then divide 4.88 by 9, so 0.542 is the sine of Q. So to solve for Q, you would do second sine 5, 4, 2, enter, and it's 32.8. Q is 32.8. So just write it on one side. Now that's the situation where Q is like this, because this would be, if the bottom is Q, Q would be like this because 32.8 is an acute triangle. But what if Q was longer? Then you'd have an obtuse triangle. So the way you solve for this Q is you would do 180 minus that Q, and you would get the Q of the second. So 180 minus 32.8 gives you 147.2. So 147.2 degrees is the Q of this one. All right? So how do we find the R? Well, add these two and subtract from 180 to get the R on that side. And add these two and subtract from 180 and get the R on that side. I'm going to do this one first since this is right in my calculator. So that plus 24, and then do 180 minus those two, and I get 8.82 degrees. Very tiny angle, R is. Now let's do this one. 24 plus 32.8, and then I do 180 minus that, and I get 123.2. And that's obtuse. So see, we've started filling everything in. All we need is R, so we just do law of sines again, using P and R this time. So we can say 9 over the sine of 24 equals R over the sine of 123.2. Cross multiply. So 9 times the sine is 7.53 equals the sine of 24 times R, because this times this equals this times this. So divide that by the sine of 24, and I get 18.5. So R is 18.5 on this side. And then you just repeat the process to get R on this side. So you would do 9 over the sine of 24 equals R over the sine of 8.82. And cross multiply. Sine 8.82 times 9 divided by the sine of 24. And you get 3.39 or 3.4. Okay, that's how you would solve an ambiguous case. Now, if you got to this point here and you got the sine was over 1, then you could just abandon the entire project and say no answer, okay? So sometimes you want that, so you don't have to do so much work. But I want to see the 2 columns, and I want to see your work showing how you got each of these in the 2 columns, even on your odds and even on ones I do on the board as examples.